Two plates that one of them has our additive on it. You know.
Okay. This is Andy Coleman and Brian Gilmore. It's April the 23rd. We're testing some plates in a little forge we have. We're testing it, trying to get a lower temperature, a steady temperature. We're using the heat gun. We have two identical steel plates, one with no paint on it, the other with 80 mils, is that correct? Yes. Average 80 mils of paint with our additive. It's a 100% solid two-part epoxy paint. And we want to see what the variation is. How much is our paint reducing the heat transfer? This is Brian Gilmore you're looking at. He's checking the backside of them now.
Right now we have a 30-degree reduction.
All right, and tell me the one with no paint on it is reading what now, Brian?
136.4 degrees.
Okay.
The one with the paint on it is reading 108.2 degrees.
All right, this is great. Now, what is our interior ambient temperature, Brian? The best we can tell. We've got probes on the interior and on the back of these pieces of metal, and we're graphing them. And we got a little bit.
240 degrees.
We're at 240 on the interior. So we expect that to keep climbing. We think we're getting more heat effect on the plate because we are having forced air in there at about, what would you say, 9 inches, Jim? 9 inches from the end of the heat gun. So we're gonna kind of, and we are graphing these two. We're graphing the interior temps and the temps on each part of each piece of steel every 2 seconds. So we're going to see how they come out. We want our interior to keep creeping up. We got a 30%, we got a 30-degree variation. We had a temperature, ambient temperature of about 87, so the one with our paint has come up 15 degrees, and the one with no...
There's almost 30-degree difference.
Well, it's 30-degree difference, but there's the one, we come from 87, what was our reading with the paint?
The paint was 108 degrees.
108, so we come up 13 plus 8. We come up 21 with the paint, and we came up from 87 to 130.
136.
So we got 36 plus 13 is 49. So we come up 21 with our paint and 49 without our paint. That's a significant difference. We like that. And we're going to continue to observe here, and I'll check back in several minutes. Brian, what are you doing now, man?
Cranking up the heat on the heat gun, try to get the internal temperature up a little more.
Okay, and we'll see what the variation. Really, the internal temperature is going to be a constant, whatever it is, and the more variation we get on the back, it's going to be. The plates are exposed to the same temp. The more variation we get on the back, it's showing off our additive more. The effect of our additive. All right, Brian. We got two plates. One with 80 mils of our paint with our additive in it, and one identical steel cut from the same mill, same sheet of steel. Identical thing.
Without our paint, we're at 250 degrees.
At 250 degrees. It doesn't matter what we are on the inside.
With our paint, we're at 159 degrees.
We're at 159 with our paint. Now, that's 91 degrees difference on a low end. So we know damn well our paint is doing a heck of a job. I don't know that we're completely duplicating the test, but we know we're cutting heat transfer way down. We're 23 minutes into this test, we got some convection. We got a heat gun, as you see, going in here. So there's some forced air in this heat, but it's equally split. And we'll do the same thing, swap sides on the plates and show the same result. That's a good test. Good test. We're showing us at 428 on the interior, and what are we on the back side?
233. And
Take it up. We're 428 on the interior, and it's not just radiating heat. We've got some convection forcing air toward these plates.
243.
All right.
Without the paint.
Without the paint, we're at 243.
162 with the paint.
162 with the paint. We're 80 degrees different, 81 degrees different. We're lighting an LP burner on this, and we want to kick up our interior temp and see what effects that has on our painted panel and our unpainted panel. Okay. What are you reading now? We switched to a LP burner, and we want it to equilibrate here, and basically what we're doing is we're getting an idea of what our interior temp is, but what we really know is that it's equal for both plates. What you got on our painted plate? Just a quick reading, Brian.
140 degrees.
We're 140 on our. What are we on the unpainted plate?
200 degrees.
We're 200 degrees. That's 60 degrees.
We're going through cooling.
Huh? We're gonna bump it on up here. Brian, show us this plate here. We kept right on and got it up to about 1100 degrees. It had just a trace of a char on the right lower corner there, but you can see all of the paint is intact. Even the writing on it is still legible. And
I'm touching it with it just coming out of 1100 degrees.
Yeah, he's holding it, and it's just come out of 1100 degree oven now. Brian, grab hold of the other plate. Alright, well, he won't grab hold of the other plate. Take one more reading. That other plate should be cooling off even faster, though. Let's kind of see what it still is. We know we didn't purposely duplicate what the test is, but we got an honest test of even more heat and with some convection heating on it, and we believe we proved it beyond a reasonable doubt that our paint really does slow the transfer of heat, and we hope this will be valuable to our potential contractor. Thank you.